Hello everyone, in this video let's discuss about Wein bridge oscillator. If you are new to our channel, please subscribe for more engineering related topics. So this Wein bridge oscillator will rectify the sinusoidal oscillation. Next, so it will rectify up to 1 megahertz. So this oscillations up to 1 megahertz, that is audio frequency range. So we have the circuit. This circuit consists of bridge like structure, so we will call it as Wein bridge oscillator. So it has the operational amplifier op-amp right here. So we are giving the input to the positive terminal of the operational amplifier. Positive terminal means non-inverting terminal. So when we give input to the non-inverting terminal, it produces a output voltage V0 or VO. So this output voltage will be the input to the RC circuit, because here resistance, capacitance, capacitor, here resistor. So let's call it as resistor 1, capacitor 1, resistor 2, capacitor 2, resistor 3 and resistor 4. So therefore this is the RC network. RC network means the network consisting of both resistance and capacitance. So this voltage will be input to the RC network. Then the output of this RC network will act as the input to the operational amplifier. So output of operational amplifier, that is op-amp, act as input to bridge or the RC network. Next, the output of bridge or RC network, output of bridge circuit or RC network will act as input to operational amplifier, input to the operational amplifiers. So now let's discuss about their operations. This R3 and R4 will be the part of feedback. So R3 and R4 are part of feedback. Therefore R1 C1 which are in series and R2 C2 which are in parallel allow only one frequency component to pass through them. They only allow one frequency component to pass through them, which will act as the input to the operational amplifier. This series and parallel combination of the resistor and capacitor will allow only one frequency component to pass through them, which will act as the input to the operational amplifier. To understand this Wein bridge oscillation operations, now we have redrawn the circuit. Therefore R4 and R3 will act as the part of the feedback, and R1 C1 in series and R2 C2 in parallel. So this is called as the RC network. RC network means combination of resistor and capacitor. Here resistor and capacitor are in series, here the resistor and capacitor are in parallel. Therefore we can call it as RC network. In this RC network, there will be the production of the oscillation. So oscillations do not need any input. They will be formed because of the thermal noise. So the thermal noise is responsible for production of the oscillations. These oscillations will produce many frequencies. That is, they will produce many frequency components. So in this many frequency components, there will be higher frequency component, lower frequency components. At this condition, R1 C1, that are R1 C1 both are in series. So this will act as high pass filter. So this will avoid the high frequency component to pass through them. They will not allow the high frequency component to pass through as to get into the input. Next, R2 C2 which are in parallel will act as the low pass filter. this low pass filter will not allow the low frequency components to pass through them. That is, when they pass through them, they will act as an input to the operational amplifier. Therefore, since the higher frequency component and the lower frequency components are avoided, one intermediate frequency component will be selected. So therefore, one intermediate component, that is frequency component, will be selected. So it will act as an input to the operational amplifier, then output will come, the output will act as an input to the bridge rectifier. So act as the input to the bridge circuit. So this process will continue. Since there is the connection of amplifier and the feedback, let's consider it as amplifier A and the feedback beta. So this value must be equal to 1. So in the Wein bridge oscillator, the beta value will be equal to 1 by 3. Therefore, what will be the value of A? If A comes down means 1 by A. Therefore, A value will be equal to 3. A value is equal to 3. Now we got to know that A beta is equal to 1. Therefore, beta value was 1 by 3 for Wein bridge oscillator. Then A value is equal to 3. So now when we consider this network, we can see that the input is given to the positive terminal of the operational amplifier. Therefore, this circuit will be similar to non-inverting amplifier. As in non-inverting amplifier, we will give the input to the positive terminal of the operational amplifier. Therefore, RC network right here in this network is similar to non-inverting amplifiers. So in non-inverting amplifiers, we have discussed that what will be the voltage gain? AV is equal to 1 plus R3 divided by R4. So that is, what is the feedback resistance we have used? R3 and R4. So therefore, 1 plus R3 divided by R4. So now we know the value of A. What is the value of A? 3. Therefore, 3 is equal to 1 plus R3 by R4. So 3 minus 1 is equal to R3 by R4. 2, if I send R4 here, so R4 into 2 is equal to R3. Therefore, 2 times R4 value will be equal to R3 value. So this resistance R4 value will be 2 times that of the resistance 3, that is R3 value. Now we got the resistance values. Now let's consider about the frequency. So I said that only one intermediate frequency will be selected. Therefore, its value will be F0 is equal to 1 by 2 pi root RC. So we have two resistances, that is R1, R2, and two capacitance, that is C1, C2. So this will be the formula. If I consider R1 is equal to R2 and C1 is equal to C2, that is, if we have the capacitors and the resistance of the same value, what will it be? 1 by 2 pi root of RC. So this will be the intermediate frequency formula which has been selected. So hope you understood the concept. If you have any doubt, please comment below. If you like the video, don't forget to subscribe. Thank you.